It's a discussion of, the impact of math circles and camps on classroom instruction. Our first speaker is Mary Fay-Zenk. And she's an assistant principal in the Cupertino School District. And I met her about 6 years ago when I came north to help out in a Catholic school in the San Jose area. And for at least the last 5 years, we've served together in the executive board of the Santa Clara Valley Mathematics Association. Along the way, we held a lot of our meetings in a classroom that belonged to her at the Miller Middle School actually it's in San Jose. And one of the things that struck me right from the beginning is, my God, there's a very gifted teacher here, because all I saw in the room were resources to support math counts, and I saw, must have been 10 or 15 years of awards for math counts. And 2 years ago, the team that she coached along with Pallavi Shah won first place in the nation, and then I think last year that team went on to win the second place in the nation. So without any further introduction, I give you Mary Fay-Zenk.
Thank you, John. Thank you very much. I think I was invited to this, and I was like, oh my gosh, so honored. And all these people that were going to be here that have been like idols for me, really. I mean, I look at your names, and I heard from you, and I'm very excited to be here. And I thought at first I was supposed to talk about 5 minutes. I thought, oh, I can do that. Then I heard it was 10 minutes. And then he just said, oh, 10 to 15 minutes. Well, I don't know if I have anything that will take that long to say to you. But I'm going to start in about telling, here's the topic, okay? The topic is the impact of math circles and math camps on classroom instruction. But they didn't have any impact on classroom instruction because they're the follow-through to classroom instruction from what I have seen. But I want to talk a little bit about math competitions having an impact on classroom instruction, because that's where it started for us. So I have taught for nearly 30 years, and I've taught math since my second year of teaching. I've always taught middle school people. I've taught 6th, 7th, and 8th graders. I taught a little bit of high school, but I didn't like it very much. So I've always focused on 6th, 7th, and 8th graders, and those children, I know more math than most of them. But by the time I get them in 8th grade now, they definitely know more math than I do. And I have kept growing in my math. I did an undergrad. I should tell you a little bit about this. Okay, so I went to college. I wanted to be a math major. I started in math classes in calculus, and they wouldn't answer my questions. I thought, well, this is rather foolish. I'm not staying in a class where they wouldn't answer my questions. So I transferred to be an English major. I did major in English, a minor in philosophy, a minor in French. I taught art, music, English. And then a math opening came the second year I was teaching, and I said, oh, I'll teach that. I love math. They said, okay. So I taught math, and I've taught math ever since. So I needed to, after about 15 years of teaching math and getting children involved in math contests and knowing I would just use the same tools the children would use, right? And they worked pretty well. I could solve almost all the problems. And then I met up with Dave Logothetti, who is a wonderful professor at Santa Clara University, and I thought about getting my master's in either educational administration or in math. And Dave said, well, you're not going to do educational administration. You're going to do math. So I said, well, I don't have an undergraduate degree in math. And he said, oh, don't worry about that. You're very smart. So I didn't worry about that. I just took everything Dave said. And I started in problem-solving classes through a National Science Foundation program. And I went to Santa Clara with all these people who taught calculus. I had never really gone beyond the second year of calculus because nobody would answer my questions, and I hated it. So I kind of did math my own way, which I think the parallel is I was just like a 7th or 8th grader who hadn't had calculus. And I was amazing. I could solve all sorts of problems based on just being a smart person. And I'm no smarter than I'm not smarter than most people. I'm just smart. And I think most people are smart. And I think we just downplay that because we don't allow the opportunities for smartness to come out. So I want to talk a little bit about that and just make sure that we honor. We're not looking for this base of talent, I don't think, that doesn't exist or only exists in this very elite group. We're trying to pull out that talent that really exists with an awful lot of young people and an awful lot of adults. So anyhow, okay, I'll kind of go on from that. So I didn't have a whole lot of academic background. I did end up getting my master's in teaching mathematics from Santa Clara University with feeling great about myself and went right back into teaching. Well, I never did stop teaching the 8th grade math. But I found that I could do more and more, and I just loved it. So all I did with my children was problem solving, and then we got involved in math counts, and first time we took 3rd in the state, I think, and oh wow, that was really exciting. Well, the next year we took 2nd, and then the next year we took 1st, and we've never looked back. We've never not gotten 2nd or 1st in the state of California from Miller Middle School. So it's a culture that we've built. And what happened after we had the fun of doing well, it really wasn't winning. It was really about doing well and finding it so much fun that that my colleagues, I went off to the district office then to be the math resource teacher for our district. And if you don't know anything about Cupertino, we're a very high performing district. We have immigrant families. These are some of the best people. They bring their children here. Best people in the world in science and technology. They come here, they want the best education for their children, and they hand them over to us. And there are challenges to that, but there are also some wonderful things. The children are very hardworking. The parents are extremely supportive. So I went off to the district office to try to create a program that would really sustain the kind of problem-solving thinking work that I had seen at my school. And was received with some, we did a really good job. Okay, so we had happy parents most of the time. We had happy children most of the time. And you can't do too much better than that. So then we found that we really wanted to sustain this. So some colleagues that I worked with, and some of you may know Neil Woolley from having done math counts, because Neil went to the national competitions and led the California team several times, along with Nona Hayden. And these two teachers created a class at Miller that I want to talk about just for a little bit, because I think this is possible in a lot of places. This is a math enrichment course, and that's what we call it at Miller, but it's an elective course, and what it does is problem solving. And it doesn't take the place of students' regular math classes, but instead it allows them to be very inquisitive, to explore topics at their level. You don't try to teach them calculus. We do not teach them Algebra 2 trig. We don't do any of the regular curriculum courses in this class. We just explore things. And it is a wonderful opportunity for children to work together. Let me see here now. All right, so I want to continue talking just for a couple more minutes about when you have a middle school teacher, or even in, and I don't mean this in a negative way at all, but even if you're reaching down into 5th and 6th grade where you really want some children to be excited about math instead of bored, okay? So when you're talking about these teachers, though, you have to remember that we don't have PhDs in math. Most people have never taken a calculus course. And you're not going to get the people who are your high-flying mathematicians being elementary and middle school teachers. So you have to support them. One of you just said, and I apologize, I didn't write down who it was. It might have been, well, I don't know who it was, said, if you haven't worked through the problem sets, you know that? Well, most of your problem sets I couldn't work through. But I'm still going to have children working on those, and I can't be afraid to do that. And I think that's where we need to be able to count on you. So I want to tell you a couple of fun stories. In our math enrichment class a couple of years ago, I can't remember, we found this neat thing in some math magazine, and it was about cutting these pieces apart and mixing, how many different ways could you mix them together. So I just brought this to class one day, and I said to the children, oh my gosh, what about if we just took a 3x3 arrangement of these things? How many different ways could we do it? Well, they were just colorations. different variations of colorations. I thought, well, this is a fairly simple problem. The children will be able to figure this out, which is the way I left most things in the math enrichment class. I didn't worry about the answers. I just figured they'd be able to figure them out. Well, after about a week and a half, we could not come to an agreement over what was the solution to this. So I thought, okay, well, time to pull in a few resources. So I called over to Santa Clara, where I went to school, and I talked to Alexanderson. Jerry Alexanderson. And I said, Jerry, can you help me with the problem? And I explained the problem to him much better than I explained it to you. It really doesn't even matter what the problem was. He said, I don't know. Let's see, Gene Pedersen's walking down the hall. Let me see what Gene can say about this. So then I relaxed because he didn't know the answer right away. So then he told me, I think that might involve that Gene thinks that might involve the Polya enumeration theorem. I said, okay, good. Now what? So anyhow, he said, come on over to lunch. Well, it just happened that I could. It was funny because we didn't have the regular schedule the next day. Usually I taught through lunch. I taught through lunch usually. So I went over there, and it was like the most fun experience I had had in a long, long time, because there were the math department at Santa Clara University gets together for lunch almost every day. So there were 8 PhDs sitting around this table, Jerry Alexanderson and Gene Pedersen and myself. And they were all talking about this problem that I had given to these little 7th and 8th graders. I felt so much better that the 7th and 8th graders couldn't figure it out, because neither could any of these people. So it was really fun. They all took a copy of the problem. I had brought some of the children's work. I think I had brought 5 different copies of the children's work. We passed them around the table, and we ate lunch for about an hour and a half. And then nobody had come up with a solution. They had ideas, but they hadn't come up with a solution. 2 of them took it back to work, and they both got back in touch with me, different solutions to the problem. One of them wrote a computer program, which one of the students had done. One of the students had written a computer program, and he was right, but we couldn't prove it because nobody else had gotten the same answer. So this little student, William Lee, who is now, I think, a sophomore in high school, figured this problem out by writing his computer program and generating all the possibilities. And then that was confirmed by one of the professors, and then another person used another technique, I think using Polya's enumeration theorem, but they had to do some other little part to it. Anyhow, that's the kind of support that, it makes me totally unafraid to ask questions that I don't know the answers to. And that's what I should be doing as a middle school teacher, given the children I have and the background I have. I can't be embarrassed about my background. I've done fabulously well. I'm a wonderful teacher. But I don't know all the math. And actually, there is that part that sometimes the math gets in the way, right? Because these simpler solutions, if they can be done better. Wasn't Steve Olson talking about that in his book? How, like, Tian Kai could do a simpler solution because he didn't have all the math yet. He was only a 9th grader. Something like that. That's pretty interesting. And then another really nice opportunity was when I called Paul Zeitz and asked him, and he did not embarrass me. I asked him for a relatively simple question, and I should have known this one, but he made me feel like, this was a good question for you to ask, and I really appreciated that. And then when Tom Davis comes to my classroom, or, when you people reach out, it's really wonderfully helpful. So don't stop doing that, please, and find ways that you can. All right. Of course, all the good things about having a special class where children can work together, a math enrichment class, and it's not that hard. They have journalism classes in middle school. Why not a math class? They have a yearbook class. It is paid for by the school. Why not a math class? The other thing that our math enrichment class does, we usually take 40 students. You don't have to. You could take 30. One of the other wonderful things about it is that it keeps us from rushing children on. And that is, I think, our biggest problem in California right now. The California standards, they thought they were doing a good thing. They have messed us up. The California standards tell you to rush ahead, do as much as you possibly can, whether or not the children understand it. If they don't finish, you're penalized. It's a tragedy. It really is. I mean, if you go to the middle school, you will see all sorts of children knowing nothing about what they're doing and getting fairly good scores on their tests. So the math enrichment class allows us to have an outlet for those children, and their parents don't complain. So we do our very, very best to keep children studying either algebra or geometry at the 8th grade level. And it leads to deep thinkers when they then apply that in math enrichment class, instead of going off and doing calculus, going off and doing algebra 2 trig or pre-calc or whatever else it is that they think is so important. It's not important. And in the, I don't know, maybe 10 years that I've been working closely with the California team, either training the team or being the coach for the team, almost always the students who are studying geometry as 8th graders are our top performers. And it's because they understand the math. And that's the other thing I wanted to make sure that I talk to you about, because I think that, and this is the last thing, I guess I did talk more than I thought I would. And somebody told me yesterday this is really hard, but when you write problems for contests that really do only involve algebra and geometry, so you really force the children to think, those are the best things for them. And I guess they're really hard to write, but the math counts problems are wonderful because that's what they do. I think the AMC 10, the AMC 8 are wonderful. I still love the CML. It makes the children be really careful, and you don't want them to be sloppy. You don't want them to rush to wrong answers and not think about what they're doing. So that deep mathematics and the care with which they need to do that work is really important for their training. And it helps them to make connections. So you know that wonderful quote by Paul, yeah, that should be on the wall of every classroom. Better to do one problem 5 ways than to do 5 problems. Something along those lines. That's the kind of thing we want for our middle school children, I believe. And so I really thank you for inviting me, but most especially for all the extra, I mean, I'm a volunteer too, but it's all that energy that you put into this that makes it so worthwhile for our children. So thank you very much. Thank you, John.
Are there some questions for Mary? Helmer?
Thank you for a very inspiring talk. I really enjoyed it. One of the things that I found most inspiring was hearing about your own background and you going and getting a master's at Santa Clara. And part of the reason why I want to ask you is because I thought it was so incredible to hear about your relationship with Santa Clara. I mean, obviously you enjoyed doing your master's there and also your future contact. And I'm sort of trying to do something similar in Singapore to create the masters for in-service teachers and to set up a network or having a contact person at each of the major schools. But I was wondering, like, how did you feel about the master's degree you took at Santa Clara? Do you think that was just a piece of paper, or did you feel that what you learned there was really useful? Which of the courses you took there do you think was most useful for your and helped you most in the future? And would you have liked to see more content, more pedagogical issues, or how could a course like that be improved?
I'm really glad you asked that, because I haven't ever had a chance to tell people about how special I felt about that program. Santa Clara is a fabulous university, as most of you know, but it isn't, and like USF, it has opportunities to work outside of a very rigid system. You know, you certainly have standards at those schools, but the standards can be organized a little differently. So all of the courses, I was under the tutelage of Dave Logothetti, who really understood that the people that I was only going to be credentialed to teach up through middle school. So I wasn't going to be going off and teaching high school under false pretenses, teaching calculus when I didn't know anything about it. He didn't make me take those courses. I did problem solving up the wazoo, right? I did problem solving and problem solving and problem solving. And so I think about, I don't know if it was 15 or 20 units of problem solving through 2 summers of NSF institutes. And that's where I worked with the high school teachers, but my approach was always a little different. And so that was very good. Then I took a history of mathematics course, and I would recommend that for anyone. That was wonderful. But then see, I'm sort of like at the place where I should be doing what Archimedes did. I mean, I'm no genius, but what he did, those kinds of methods, I can do those with algebra and geometry, right? And those are the kinds of things that we as middle school teachers should be able to do and should be taught to do and have the opportunity to explore without being afraid. I don't need calculus for that. I don't need analysis. I don't know what else I don't need. I don't even know what I don't need, right? Like, I don't care. It doesn't matter to me, because what I want to do is get these young minds thinking about the foundational pieces of mathematics. So that's the kind of course that Dave directed me to. I took a course that I remember very well in non-Euclidean geometries, and that was wonderful for me. I did a research paper, excuse me, I didn't really do a research paper. I did, I wish I could remember the title of my thesis because it was really cool. It's been a long time now. I studied Pascal's triangle in n-dimensional cubes. And there were no computers then. I couldn't see these. I had to imagine and draw them. And I studied, I mean, I did a lot of artwork. I'm pretty artistic. And so I found that rather wonderful. And I teach polyhedras with my children, and I can help them find the different, you know, like a hexagonal shape. And I mean, I can do that stuff with my kids. And so I'm trying to remember if there were, I know there were a couple of other courses I had to take, but I can't remember them by name. So I had to do 45 units. I mean, I had to do a substantial amount of work. But it was always with an eye to, I wasn't going to be an engineer. I wasn't going to be, you know, something. I was going to teach middle school math. What would strengthen that? So I think you need to look around. Certainly now, there should be now some emphasis in technology, where you can use technology to teach children.
So the emphasis was on content, not
Absolutely content. Yes, absolutely content. It was not doing research on who was doing math education. Oh, I think that's a waste. I don't want anybody to do that. I'm sorry. Somebody might have misunderstood. Oh, that's terrible stuff, I think. Educational research, you just need to get in with the children and see what they can do and not be afraid to let them go.
Yeah, a couple of questions about your problem-solving class. Is it 6th through 8th, or is it an 8th grade class? That's number one. How many children do you have involved in it? Does it evolve much from year to year, or have you sort of standardized it at some point? And do you have a textbook? And do you have a textbook, or do you just draw from a variety of sources?
We have, I still want you to go back to your middle schools and start this, right? I mean, I know you don't teach there, but you're the parents, many cases, and you could do this, or you could volunteer and you could run a math enrichment class. So what you do is you figure out who are your children, and you might start with some contest problems, but what we did was we have basically a 2-year curriculum. We have 7th and 8th graders take this course, and the curriculum is very fluid. I mean, we have it written out so we can show people what we would do in a 2-year cycle. But if it doesn't work, we don't do it, right? You see the lights in their eyes, or you don't see the lights in their eyes, or you change. And so this has evolved, and it evolves according to the strength of the teacher. I'm one of 5 different people who have taught the course over the years. Oh, I should have said something else. Miller has really done well in mathematics over the years, and these are exceptional children in many ways, but I really don't believe they're that exceptional. You could recreate this in many areas. All you have to do is build the culture that math is fun, and other people besides you want to do it. So then, at our last year, I was still the math coordinator for the district, and we started a math enrichment course in each of our middle schools, and that I'm very proud of, because it took almost 10 years to get the elitism out of that, to have people know that it wasn't about being elitist. It was opportunities for children to learn more math. And so now we have, at 4 middle schools, we have math enrichment courses, and they are all taking on a slightly different flavor. I gave them everything I had. We just took all the buckets of stuff, you know, all the files, brought them to the district office, made copies for everybody of everything they ever want to do, even the funny little problem that I needed Santa Clara to solve for me. And then they will make it their own. So we usually invite 7th and 8th graders. We have had 2 children come in 6th grade, 2 very exceptional children. And did I answer most of your questions? Okay. Well, we have 40 students in the class, 39, 40, it varies. And if a child joins the class and they don't like it, we let them out immediately. And we do once a week. We started last year. We do Richard's class online. We do Richard Russick's Art of Problem Solving. And so all those little children sit down at the computers and they sometimes goof off, but mostly they do math. Correct? Most of the time. I can't monitor them all, right? So I don't worry about it. That's part of it. You don't have to worry about it. We give them all A's unless they are really not focused.
We'll take one more question from Zvezda, and then we'll have some time later.
This is not a question. I'm saying it out loud now, so you know. Every year at the Barry Math Olympiad, we have been grading, and the results come out. And in the youngest age group, Miller Middle School comes up over and over and over again. So now I finally know why. And my second comment is, you mentioned that in your school there are special classes in journalism and in other subjects. And in fact, that rings a bell. In Bulgaria, in my middle school, there were circles in just about every topic. There was a circle in math, in physics, in chemistry, in poetry. I went to the poetry one before I started going to the math one. And everyone thought of these circles not as a place for elite kids, but as a place for them exactly to do what you are saying, to explore their abilities, whether it's sports or math, it is all important. So if we indeed can get away from this common image, popular image of math being only for a small fraction of people, then we will be successful. Thank you for your inspiring presentation.
There was one more thing that was really exciting. I didn't write it down this time. There was one more thing that was really exciting, and that was last year. This is typical of the class, too, of Math Enrichment class. So there was an article in Teaching Mathematics in the Middle School, and it just had some questions, some little funny question about here's a rectangle or a square, and then here's a trapezoid within that, and if the whole square is worth $1,000, how much is this trapezoidal section? So I brought it to the children one day, and I thought this would be a good warm-up because I like to have them write about math. So I said, now this should probably take you, it's a really easy problem, don't put it down. I want you to write how you're thinking about it. See how many different ways you can solve it. So I thought it would probably take them 10 or 15 minutes, right? 45 minutes later, they were all still writing. We got, one boy wanted to take his home. Jeremy, if you've met Jeremy Fang, he is a great kid. He wanted to take his home. He found personally 7 different ways, I think, to solve the problem. So we had a little editorial board the next day. We had such wonderful responses from the children. So they got 5 girls together. I think we were all girls this time. And the girls were the writers, typically. And they were the editorial board. They found 13 different solutions. They went through all the papers. They found 13 different solutions, and we sent them off to the magazine, and they were published. And it just kept saying, and another Miller student, and another Miller student. And we were all so proud of that because it wasn't our high flyers typically who were published there. It wasn't anybody on our math counts team. It wasn't anybody who was at the BAMO. It was our regular, wonderful, terrific, hardworking students. And I think there are just so many ways to go with this, but you need the opportunity for the children. That's all you really need, just the opportunity.
Thank you. Let's give Mary another hand. Our next speaker is Tom Reich. I know Tom as the guy on the other side of the pond. He's a retired mathematics teacher from Oakland High School. He spent 34 years teaching there, and he has been involved with the Berkeley Math Circles since its inception. He's a graduate of San Francisco State University. Tom.
Ever hear the expression, hard act to follow? Yeah, I spent 34 years in Oakland teaching, starting out 6 years as a middle school teacher, and then went over to Oakland High School and remained there until 2002. I'm now a volunteer teacher at Oakland High. I go in 3 days a week. My image of what this particular presentation was going to be was a panel, and I thought, oh, I can hide in a panel pretty well. I'll just sit there. That's sort of been my my usual modus operandi. I don't think I ever stood up in a faculty meeting in the 30 years and ever said anything. I went all the way through high school being an isolate, and whenever someone looked to see if I had an answer or something, you know what an isolate is anyway, the person who never stands up. So unfortunately, here I am. I interpreted the charge here to actually give the impact of math circles and math Olympiads and math competitions on the classroom instruction. And I think I heard yesterday from John the appropriate answer there. He said the only thing that kept me going was the extracurricular activities. It's a hard job. I was lucky enough to have a wife for 30 years that allowed me to do the job. I usually arrive at school at 7 and leave at 5, and I never touch any of the work that I have to do until I get home and finish dinner, because I'm constantly engaged with students for the time that I'm at the school. The competition aspect began with the Santa Clara math contest. One of my junior high students left the area and came back to visit me, and somewhere out in Hayward he had been taken down to the Santa Clara contest and gave it to me, and that was kind of exciting. So when I got to the high school, the first contest that I was able to go to was that Santa Clara contest, and took some kids down there. That was pretty exciting. Of course, the AMC was a part of my high school background. I didn't get a negative score, but I don't think I got a score over 10. Throughout my career, well, I actually went into the Navy right out of high school, and then started college at 21, and spent as much time as I could there, until Hayakawa took over San Francisco State. But an amazing thing sort of happened to me there after I graduated in mathematics, magna cum laude, and then I went to the library and I took out this little book called USSR Math Olympiads, and sat down and started trying to do some of the problems. And it was rather disturbing that with my degree in mathematics that I couldn't solve those problems. And so I felt rather inadequate at that point. I continued on to try and get a master's degree. Maybe that would help. It didn't really, honestly. And in any case, I went over. I was out on the picket lines and other things, and met the education instructors who were out there along with us. So when I came back in, I got my teaching credential, and ended up in the middle school. I don't think I would have made it through all these years. In fact, I almost didn't make it through the first 3 years. I had a principal who said to me, "You are here not to be friends with these students, but to teach and discipline them." And that doesn't fit very well with my personality. And luckily, the principals changed the second year. So by the third year of my tenure, we had a new principal who was more, well, he at least encouraged me in my efforts. And so I managed to stay on in the middle school, and I don't think I really wanted to leave after 6 years, but an opportunity occurred at the high school. Middle school students are very much as Mary described them. They're so full of energy and curiosity, and they want to learn. And I had a small cadre of students that I worked with. I had the chess club, and I taught them how to play Go. In fact, one of those students just came down the other day. He's now around 40 years old or so, I guess, but he beat me in Go. So anyway, back to the math competitions. We had the University of Santa Clara contest about the same time the California Math League started, at least at Oakland High School in the 70s. And the Brother Brousseau contest. Oh, there's another Joaquin Miller story there. I taught calculus because the teacher didn't want to have 2 preps. And so he took away my advanced algebra class and says, "You teach the calculus." And I took my calculus students over to the Brother Brousseau competition, which was held at USF at the end of the year. And they got out of the car, and all of a sudden these 2 big buses come up, and probably about 120 students, it looked like, about this high, all come running out, and my kids are feeling pretty good. And at the end of the day, Oakland High School students had the lowest score of any of the students there. And of course, Joaquin Miller walked away with the prize in the middle school, or the junior division of the thing. So it was sort of an awakening for students in Oakland who were number one, and they were certainly number one in Oakland, but they discovered that there was something else going on out there. So it was very good for us to go through that experience. By the time the Brousseau competition ended, which is about 7 years later, I think, Oakland High came in 3rd place in the division. Well,
I'm so sorry. How rude.
it's okay. We need a little of that interjected into my style. First time I've ever had one of these in my hand, so hope is not all that comfortable. But math competitions just became a way of getting these kids involved and closer to me. Right after the Brousseau competition, which I started distributing to the school, I was still teaching math workshop and other things, mostly at the school. But 3 students came up to me and said, "How do you find out about these things?" Because they couldn't solve the Brousseau problems. And I told them that if they could get 5 students, then I would sponsor a math club. And the next week they came by with 5 students. And there's been a math club at Oakland High since that time, for the last 25, 27 years or so. and is still going, even though I have retired. I go back there on Tuesdays and run the club and try to mentor one of the new teachers who is only been there a couple of years, but one has voiced an opinion that she would try to take over. She could only get her head above the water. And I think I heard some opinions throughout this about teachers. Why can't we get the teachers involved in that? Just out of curiosity, how many high school or middle school teachers do we have in the audience? Okay, and then very good. I didn't think there were that many. And that's a real difficulty. I mean, I've been promoting this event for the last 5 or 6 months. Is it 5? No, about 4 months. Yeah, since August, with all of my contacts, and nevertheless, it's just one of those things that teachers just don't have time to do this. It's amazing how overwhelmed they are with their job. So let me just talk about a couple of other things here. Math camps. I did have a student who went off to Promise one year and came back, and as required, came to the math club and gave his presentation on what he had learned at the math camp. So it certainly was a wonderful thing. He was a student actually that I took down to Stanford on Sundays with when Ted and Josh and Paul, in fact that's where I met them, held an 8-week problem-solving seminar to do something about the lack of participation by West Coast students in the Olympiads. And I think that we, given our aim at that time was to improve the participation, I'd say that you guys were pretty successful in changing the climate here. And I guess I should mention the Arnold Ross program as well. I had a student who did go off to that camp, and in fact, when she was getting her PhD at MIT, came back and was a counselor at the Ross program. So definitely, those kinds of things make a big impact on students. I think the USAMTS was also an important contribution to that particular person, that she was able to send off her correspondence and get real mathematicians to look at her work and send back replies. She was obviously beyond me, although we sat down and talked occasionally. The very first day, Dimitri said something about people need to know about it. We need this outreach, and every teacher needs to know about what's going on so that they can direct their students. The Berkeley Math Circle has a program outreach in place. I happen to be the person whose email is on our webpage. I have received one email all year so far, and that's a young woman down in Los Angeles who wants us to come down there and provide some sort of examples of what a math circle could do. So if you think that of some way to advertise it better, I would like that to take place. I think that came up the other day when we were talking about all of this is going to be on the web, on a special page at MSRI. But if it's sitting on the web at MSRI, how many people are actually going to hit on it? The important thing is to get all those links out there so that the first 100 hits on Google that say anything at all close to it are going to link right to that page. Then maybe you'll be able to at least make the connection. What did someone said? If a teacher can do anything outside the normal, was that you, outside the normal routine, they're to be commended, and I agree. and I'm not talking about myself. I'm really an exception to the rule, in the sense that I have a wife who has supported me for 30 years, allowed me to do all of the things that I do for my students, and I don't expect that most people would be able to put in 14 hours a day on math during a school year. I do it because I enjoy it. It's fun, etc. As you can probably tell, well, maybe you can't. I would not classify myself as a very good teacher in the sense of being dynamic. I don't string sentences together very well. When standing in front of an audience, I get tongue-tied very often, can't find the right word, until I get to the blackboard and start putting some equations and figures on the board, and then I get excited, and then everything flows. I think that my strength has been that I bond with those students after a couple of weeks of being there. Those first couple of weeks, I'm just about as deadpan as I am right now. Seriously, they don't know me, I don't know them. They're wondering, how did I get into this class? I thought he was a good teacher. And it takes a while to warm up and for me to find out who you are and how we're going to work. They find out that I'm there because I really care about them and that I'm going to try and help them in any way I can accomplish their goals. That probably, along with being able to do some mathematics and it doesn't have to be at that level, as long as you're just competent as a math teacher, and if you care, I think that those two things alone will get you by. I'm just like you. My students very often go right on by me. So I didn't even look at what time I came up here. How much time have I spent? You're about there. I'm about there. Give me a few more minutes then, because I did write some things down here that I wanted to say. Sorry about that. In terms of getting things impact, you want to make an impact, you've got to have a critical mass. At least 2 students in a classroom that are vying with each other. If it's just one lonely person there, it doesn't work very well. It happens, but it just doesn't happen as well. When you have 2, then they just continue to push each other up. I didn't say all of the wonderful things I wanted to say about math circles and BAMO, which I've been involved with since its inception. It's certainly changed my life. I no longer have season tickets to the opera on Sunday. Because I don't want to miss a session of the Berkeley Math Circle. It's not so that. And let me see. I had a, I heard Archimedes there a moment ago, and I read something about Archimedes just recently too. And I wanted to say, because I felt that, Zvezda was up here the other day with, 70 or 80 adults out here and a small little group of students in this little area here. And I don't think the dynamic of the math circle really came through for those of you who may have been watching. It's usually... well, anyway, her technique is superb. I try to emulate it. When she presents something, she comes up there and has something on the board for all of you to look at and say, I could never do that. What is she talking about? And 2 hours later, people are up there doing it. Even you are saying, hey, yeah, I can do that. And I was reminded by that because I just picked up this book the other day by Corner on analysis. And in the beginning, he has a quote from The Life of Marcellus, and I was immediately reminded of Zvezda in action. He said, Archimedes concentrated his ambition exclusively, can't get my mouth working here, exclusively upon those speculations which are untainted by the claims of necessity. These studies, he believed, are incomparably superior to any others, since here the grandeur and the beauty of the subject matter vie for our admiration with cogency and the precision of the methods of proof. Certainly, in the whole science of geometry, it is impossible to find more difficult and intricate problems handled in simpler and purer terms than in his works. Some writers attribute it to his natural genius. Others maintain that phenomenal industry lay behind the apparently effortless ease with which he obtained his results. The fact is that no amount of mental effort of his own would enable a man to hit upon the proof of one of Archimedes' theorems. And yet, as soon as it is explained to him, he feels he might have discovered it himself. So smooth and rapid is the path by which he leads us to the required conclusion. From The Life of Marcellus by Plutarch. Okay, I'll leave you with that. Thank you.
Are there any questions for Tom? Paul Sides.
Hi. So I've known you for a dozen years, and you've been a real hero to me. And actually, that's part of the problem, because you alluded to your exceptional, the fact that you are exceptional in your dedication, and you've talked about how you're trying to mentor some teachers. And I've noticed at a lot of math events that we've been at together that you've had a bunch of Oakland High people in tow. And I've never known what you're doing with these people completely. Because the large question is, how is it working out? And the same goes for you. I mean, are you able to replicate yourselves, or even make kind of inferior photocopies, but something to keep it going? Because these things you talk about depend, it seems to me, to a very large degree on your own energy and charisma.
Yes, one of the teachers who actually went to the same high school as I did 12 years later is now the head of the department at Oakland High, and I was somewhat responsible for getting him hired because I noticed him when he was at the middle school that I had taught at, and I run a middle school math league in Oakland, and he was there and then came over. Now as the head of the department, I notice now that every day he's putting up problems of the day from Dimitri's book math circles. And so, yeah, I think that maybe there is a transference there, and also this young woman from Taiwan who is well, she's not so young, but middle-aged, will fill in for us and carry on Oakland High. Oakland High will not win the BAMO in the next 10 years, I don't think. But there you go. But then again, 10 years ago, Oakland High was, I think, the strongest math school in the district, and I would have said that Tech never would have had a BAMO winner. Oh yes, Gabriel did show up, so you never.
There were, yes, we'll pass this over.
Thanks. I was just inspired by something that Tom said 5 minutes ago, and I think I have a very interesting question for him and for all of us. You just mentioned that we need our pages or our main page to be the first 100 results of the Google or whatever. The problem is that if you type in something like mathematical circle in Google and hit search, then you would probably get all the first 5, 6, 7, 10 pages, not only about mathematics, which is natural because it says mathematical there, but mostly leading to the sites about math circles. The problem is that the kids and the parents and the teachers, they will not type in mathematical circles because they don't know the word, well, I mean, they know the word circles, but they don't know what to type into that. So the first, it's a two-part question. The first part is, what will they type in there? So that we can probably then go and try and hijack the Google results by putting in those keywords in all of our web pages. But the second problem, much more interesting from the mathematical point of view, oh, this is much better, is to try and solve Google equation to calculate the Google to -1 function. Namely, if we know the 100 websites we can gather, right? The 100 of the websites that we have about math circles and leading some databases, math problems, etc. How do we calculate the phrase that must be typed into Google to bring up all those results? And that should be the ultimate advertising tool for us. It could be something like, whatever, something from Lewis Carroll, and then there would be advertising pages everywhere. And so that's the question. The first part is easier, and maybe we could answer that right now. I'm hoping Tom could try and answer that. The second part is for all of us to ponder upon. Thank you.
I have one suggestion that may sound a little strange, but because you have really inspired quite a lot of kids, Tom, I think they wouldn't be adverse to providing the kind of slave labor that graduate students are often asked to do. I bet that they would be willing to help to get an email list of the emails for all of the high school math departments in the state so that it would be possible to send emails to all of those departments in unison with announcements of things that might be helpful. The thing is that that would reach the schools that are not part of the loop, that are kind of left out. And I've seen how inspiring you've been, and I bet that some of those kids you've inspired would be willing to help with the project. Also, there's innocent bystanders like me who'd be happy to help too.
Thank you, Herbert. Let's give Tom another hand here. Thank you very much. Our next speaker is Jim Tanton, and he doesn't remember it, but 20, 21, 22 years ago, I used to wander around Fine Hall at Princeton University. I was kind of a nocturnal wanderer, I guess, and I met him as an enthusiastic young graduate student one afternoon in a common room, and he took his PhD at Princeton in 1984. He worked for the Kaplans at the Math Circle for a period of about 3 years. He wandered through other teaching environments in the greater Massachusetts area. And he's now at St. Martin's School in Massachusetts, where he is the director of the St. Martin's Institute of Mathematics. And he put together a truly interesting book, Solve This, which is published by MAA in 2002. And on a personal note, 2.5 years ago, I didn't know who the attributed person was, but he had a wonderful website on graph theory, which was on the Boston Mathematics Circle. Jim.
Thank you. Can I have the blackboard? Can someone deal with this? And while that's happening, this is going to be a mystery for the videotape. So I read one educational paper in my life. And it said, well, the only thing I remember from it, is that the average attention span of an audience in a lecture format is 37.5 minutes. We're going to have a commercial break right now. This is the break. Put your hands out in front of you. Everyone. This is going to be the mystery for the videotape. Right over left. Palm to palm. We're not doing it. Thank you. Wiggle your little fingers. Wiggle your thumbs. Wiggle your little fingers. Then do this. That is the math club salute at, sorry John, St. Mark's School in South Corey, Massachusetts. Yeah, St. Mark's. This is my handwriting, I'm sorry. Now I'm back. The impact of math circles and math camps on classroom instruction. Actually, I don't have to talk. I guess I'm fine now. I've had about 5 different versions of what to say for the last 72 hours in this moment. Obviously, I bailed out my talk on, what was day, Thursday, and did something different. I think my example was meant to be saying something. I'm not quite sure if it said what it said, but it said something. I can tell you the answer. The answer to the question. The answer is a circle. This question. Take an angled piece of paper up between 2 dots. Turn it around. What curve do you get? Some people said ellipse, some people said something strange, some people said circles. The answer is actually a circle. Just do it once and it looks very much like a circle, so much so that it is one. My point is, I mean, this is the converse of what is the inscribed angle theorem or something, whatever you call it. I don't know what you call it. Proving that converse is hard. You can do it. But I had one lad in my class. He is not a top student. Maybe I can't remember what he's scoring right now, grades. He's got a C, if that means something to anyone. He's the one that's taken hold of that problem and come up with a pretty messy proof that this is indeed a circle. He can locate the center of the circle. He can tell you what the radius is. The proof is obnoxious. He's not satisfied. It's not a pretty proof. This kid knows nothing. He's a 9th grade student. I have no idea what his background really is. He is still working on it. He worked on it over Thanksgiving break. I'm sure he's working on it right now. I've been cranky the last few days, and I apologize for those people that have met me, because I've actually been a bit cranky. I don't know what the question is that we're dealing with here. And I'm also worried that there's a potentially dangerous message that we're giving to high school teachers. Tom said it. High school teachers are overwhelmed. I was teaching at a teaching college who had a course load of 3 courses per semester. That was a heck of a lot of teaching. It ain't nothing compared to what I'm doing now. I'm teaching 4.5 courses now. These courses don't meet 3 times a week. They meet 4 or 5 times a week. On top of that, it's not a 12 to 14 week semester, it's a 17-week semester. If I actually measure the number of contact minutes per week, it's more than double than any teaching college I've been at. But that's not the end of the story, because I have way more office hours than I'm ever used to. I've got way more demands on young kids that have other issues than just mathematics. I've got parents I'm dealing with. I'm advising kids on a whole way to navigate through life, academic and otherwise. I'm in a strange position. I'm not actually coaching a sport, but typically I'm meant to be coaching a sport for 2 or 3 hours a day. I'm on dorm duty, and I'm having it pretty good because I'm in an independent school. I don't have to speak to state standards. Other schools do. I have to do that for the AP Calculus exam, and yes, I can teach calculus. In fact, I'm teaching calculus much like I teach in college, but in the back of my mind, those AP exam writers have a particular mindset that needs to be addressed and I have to pay attention to, whether I like it or not. The public school teachers I've worked with really have a tougher time. There's the state standards. They've got continual pressure to produce demonstrable success. That assessment issue, what are grades? How do you deal with it? They've got to do it. Some teachers are such that every section of a particular class has to be at the same place in the textbook from week to week. Imagine teaching a college course like that. I don't know if anyone does. I think maybe some places that do. On top of that, imagine you are told that we have a shortage of math teachers this year. I know your background's history, but you're going to be teaching Algebra 2 next year. So, double your current teaching load if you're a college professor, and work in a field that you're not trained to be teaching in. That would be your life as a high school teacher to some extent. It's scary. And exactly, if a high school teacher can do anything more than just get through the day, major, major applause. But then I've still got the questions. I asked this what if question yesterday, and I don't know if I even agree with me asking the question about should high school math be given a different name? Look at what high school teachers are faced with. I mean, I could walk into a class and teach the quadratic formula in 15 minutes. I can say, here's a formula. You use it this way. Look, it works for these 3 examples. Let's now practice for the next 20 examples. Now, if I'm under pressure and that the textbook does something like that, that's very tempting and easy to do, and maybe even be appropriate, because sometimes high schools are just charged to get through a skill set. Don't worry about teaching what math is. And maybe that skill set is valid, because I know statistics courses in colleges, like in the psychology department, which is very much a black box approach to statistics. That's valuable sometimes, and maybe that's fine for the high school setting. I don't know. I don't know how to answer that question myself. But I'm worried about the disconnect I'm hearing here. What are you wanting high school teachers to do as mathematicians? Now, that's a very personal question for me, because I've left the tertiary scene to come into the secondary scene myself, because I'm very intrigued by that question. And you've seen my style. I mean, I take a problem that's in a textbook and I can turn it around. And that's because I've had the luxury of years of reflecting and thinking about mathematics. Those that go into the high school scene, you really don't have time to think. You just don't. And for the love of me, I could say, wouldn't it be great to have a math department that's based on the college model? That teachers were only required to teach 2 courses per semester or year, were required to produce some original work and thought, maybe write little papers or at least, some sort of notion of extracurricular work or reflection. What impact would they have on the classrooms? It'd have a great impact. But it's not going to happen. It's just not going to happen. There are standards to be met, skill set to be given, and that's just a fact. And everything that's been mentioned so far is always extracurricular. That's fine. It'll have to be extracurricular, I guess. So I'm totally confused. I just don't know the answer other than it's a circle. Yeah, actually, I don't know the answer. That's it. That's all I can say. I mean, there's more I can say. I can give you like cute little tricks that I've had a chance to think about. And I am discussing it with my colleagues. I am doing the best I can to get it out there. I write, I do everything I do, I just do more of. I've written books and so forth, all to get out the idea of how to think about math in different ways. But I can't expect people to internalize that for themselves in the current situation they're in. Yeah. All right. I'll stop there then. Thank you.
Are there questions? Are there questions for him? Yes.
Well, I'm intrigued by a lot of what you said. I agree with everything you said. Although the converse of it, I don't quite buy. College teaching, for example, is not all that great either. And they have all those luxuries of things. And so in terms of what the missing ingredient is, I'm not sure that that exactly touches it. Although certainly all these constraints that high school teachers have is absolutely right. And there's got to be something more than that. And do you have any sense of what that might be?
That's a tough one.
That's a tough one. What I would like to teach, no matter what rigid structure I'm within, is flexibility of the mind and adaptability. And I'm trying to figure out how to do that. I did that in my calculus classes in college, where there was a very fixed curriculum, and I felt that push to get through it. I felt the push to get through Stokes' theorem in the multivariable calculus classes. I know the physicists needed my kids to get to Stokes' theorem in the end. That's hard. But it can be subtle to teach adaptability, flexibility of mind. That's all I can say to that. And I do it in my style. Other people have totally different styles for that.
Thank you. Mark Saul.
Well, I have a comment and I'll stand over here. I have a comment and a question. I'll hide from the camera. A comment and a question for the entire panel. I've been listening, and my background is from the classroom, so I've been the person that you've been lauding. But I'm not anymore, so I can talk freely about it. I see rather a different connection between math circles and what happens in the classroom. It's not that the teachers have to go and do something extracurricular that's in the circles, although I think they should. I think it's wonderful when people do that. But I think that the regular teacher can learn from the mathematical circles, from that approach to mathematics, how better to teach the average student. I know that's saying a mouthful. I know that's not simple. And I absolutely agree that the teachers in this room are the exceptional teachers. But you have to look at the exceptions if you want to learn what's going on. Just like in medicine, you want to look at the person who has HIV infection but did not get AIDS. Then you learn something. So you have to look at the person who entered teaching and did not fall into a rut. And can you spread that to other teachers, other people like that? Two other comments, and this goes very, very deep, and I don't have any more answers than you do. But one is that I think you're absolutely right, and this is something Deborah Ball has pointed out, and it sticks in my craw, but I think it's true, that we're not going to get a lot of excellent teachers. We're not going to get the best people who know the most mathematics and the most gung-ho for it in teaching. We have to find ways of making ordinary people into good teachers, especially in the elementary and middle school levels, where they see themselves as mathematicians second and teachers or something else first. And that's a difficult job. But I think the math circle experience has something to convey to them. And I think my feeling is that some of the reform curricula begin to implement that, but we have to think a little harder about it. And the other thing, which is, this is the worst news of all, I think, is that we don't have much to choose from. People are not going into teaching, especially not math teaching, and when they do, they are not staying in teaching. So we have to worry about the pulse rate of the teacher in front of the classroom as much as their mathematical knowledge. And I don't know what to do about that, because that has to do with the fabric of the society and who it chooses to be a teacher.
Right there. Bob Kaplan has a question.
I don't know if it's a question. I'm sure it's certainly not an answer. One of Shakespeare's characters says much virtue in as if. I think Kant said something about as if also. I think we should act as if math circles the math circle in our style, other math circles, could actually spread into the official public and private school circles by retraining teachers, retraining them in several ways. One, to like rather than loathe math, to see it as having potential, to see it as having that flexibility, Jim, that you talked about and teach so well. Why not? This is the law of the lever we're talking about. We want to, instead of each of us teaching a few students, we want to get to the teachers who teach each of them more students, and then influence all of them by teaching math circle approaches to teachers rather than to students, even though I'm sure most of you, like us, prefer to teach students. Teachers are hard to teach or reteach. But wouldn't that be a nice, unrealistic approach?
We have another question.
Well, sort of more another remark, actually. This may be as good a time as any to mention. So I've had the same sense of despair, I think, or use whatever word you like, that Jim has, partly because I've also been in that overload situation as a teacher. And you saw it yesterday when I was directing my remarks to you. But I think the main challenge is to address what Mark is saying. How do we get these teachers who are, who don't have any time or any inclination to see an alternate way of teaching or discover this potential for a lovely subject, actually to come to a math circle setting and show them a new approach. And the only thing that crosses my mind is if so here's a random idea. Do what you will, and that is if we were able to award, say, teacher development, like professional development credit for something like this that was offered in late August, shortly before the school year began, right? Maybe there's a chance that you could start to draw a few teachers who otherwise would never step into an extracurricular activity, and then be able to take back a few ideas with them to their classroom. Or, it's going to take we'll have to work through channels that are in place, right? If we're going to have any chance of reaching some of these teachers.
We still have a lot of questions to come, and I want to get Dan Teague's and then move ahead, but I want to make a comment back to Mark Saul. One of the things that comes out of this particular session up here, this panel, is that you have the position, and it's a wonderful position, as Director of Elementary, Secondary, and Informal Education. Okay, not Director. Okay, but you have a new leader within the National Science Foundation, Arden Bement, and he is a tremendous supporter of both mathematics and science education. And you and I need to talk later. I'm willing to write a letter, but better yet, I ask you to find a way to Arden and tell him what happened in this conference and try to provide the appropriate pieces of video clips to him. He will make a difference in education. And the specific thing that I have in mind is a resurrection of the Polya-type problem-solving courses that came from a very earlier period of time that were emulated around the country. We're talking about gearing those to elementary and middle schools. That should be the target area. It's going to be wasted if you go to the 9th, 10th, 11th grade. I want to get Dan Teague, and then we'll continue with Joshua.
Well, I want to say this well, and I'm not sure that I can. I think this group can be enormously helpful to teachers, but you have to be welcoming. This is not a welcoming group for a high school teacher. As a high school teacher, I've been described as, at best, irrelevant, possibly the problem. I don't know anything. I don't know any mathematics. I can go down the list of what's wrong with me. And if you're thinking about people viewing this conference and getting excited about math circles, I don't think that's going to happen. And I'm saying this because I think it's something you really need to think hard about. As someone with a degree in mathematics education who is damn proud of it, again, I've been dismissed, and my work has been dismissed. So this is not a welcoming group. If you're going to work with teachers, and you can and you should, you have to approach them as valued people. not broken people that in your knowledge you know how to fix. Okay, and I'm not hearing what I had hoped to be hearing from this group.
What can you hope to be hearing?
I hope to be hearing that I have something to contribute to my students. Most of what I've been hearing is a way of bypassing the teacher, of making the teachers aren't doing their jobs. So we need to bypass the teacher and do what the teacher should be doing. That's what I'm hearing. I think that's what teachers, when they view the videotape, will be hearing.
Wow, that's really interesting. How long have I known you, Dan? Over 20 years, right? And you're another one of those teachers. We met at Princeton, and Dan's an exemplary teacher. And I think out of this thing, I see in him some of the same pain that I feel in my heart, because we have institutional barriers that prevent us from accomplishing what we really want to accomplish. And what we have to do is create our own islands of excellence outside the normal classroom to make that difference. And I see you almost holding your heart over here, so I'm going to take one question from Zeitz, and then we'll continue with the next speaker.
Well, again, this is more of a response than a question, but I think that the issue is, you know, as we can see, amazingly complex. But I think we all have the same goal in mind. To paraphrase what Abby Thompson said, we just want to raise the level of love, and math circles can do it, and also enhanced standard math teaching can do it. And to pervert Mark Saul's analogy, I think a better analogy, rather than immunity to HIV, would actually be trying to infect a population. Because, again, using this love analogy, we're talking about seduction. And I'd like to think of the teachers in this group as infected agents. And our job is to kind of help you spread the disease in pretty much any way we can.
Well, I'm for a very rapid epidemic model. Our next speaker is Josh Zucker. I met Joshua about 2.5 years ago, maybe 3 years ago, when he showed up to a San Jose math circle. And he showed up driving a vehicle that has 2 wheels, and he had a strange-looking helmet and funny-looking shoes and long hair. And he didn't look like a graduate student from San Jose State. He was too well-dressed. And so I learned a little bit more by at least attending several math circles that he did just an absolutely gifted presentation. He took a master's degree at Stanford University, undergraduate degree at Stanford in mathematics, a master's degree at Berkeley. He went on to do work with gifted and talented education at Stanford. He teaches at the Castellea School, and his reputation, shall we say, diffuses through the Bay Area. Joshua.
Well, thank you very much. That was very flattering, considering yesterday I was on a panel about how to write problems on which I was by far the worst problem writer of the crowd, and today I'm on a panel of teachers in which I'm by far the worst teacher of the crowd, so it's a little bit reassuring to have somebody up here saying nice things about me. There's a certain kind of arrogance it takes to do math. I think you're probably familiar. You know, I have some of this arrogance. I'm sure a lot of the mathematicians in the room can way outclass me in this category. I think one of the dangerous things in this whole math circle game, one of the barriers to teachers entering is that they see that arrogance. They see, oh, I'm not as good as this person. They're going to show me this arrogance. They're going to tear me down. It takes a really special kind of confidence to enter into that world and try to survive. And it's the kind of confidence like Mary really showed in her talk about what she thinks of her math abilities and how she's going to present that to her students that really enables people to break through that barrier. So I think it's really important to talk about arrogance and confidence and what they really mean. I usually don't experience much in the way of failures of confidence, but being on that panel about problem writing with these people who are the nation's best problem writers, what am I doing up here, is really opened my eyes a bit to what I think a lot of the high school teachers feel when they're invited to participate in this kind of thing. So I think it's an important thing to keep our eyes on. And from Tom's talk, I think the key thing that he's told us is that the reason his students were there is because they knew he was always there for them. And I think we in the Bay Area math circles know Tom is always there for us, always going the extra mile to do everything. Really amazing stuff. Really fantastic. And Jim, well, I would say something nice about his talk, except he stole all the things I was going to say, and so I'm a little bit upset right now, but I'll see if I can somehow manage to get around that somehow. But first of all, I want to thank Castellea School. Not only did they pay a substitute so I could be here Thursday and Friday, but when I got the invitation to the conference, I started showing it around to my department head and some of the people in the administration. They said, not, well, what is this weird thing and why do you want to go? They said, great, congratulations, go. And what is this, a Russian Mathematicians convention or something? Read the program. And also thank you to the organizers, not just for organizing this event, but also for the difference they've made in my life since 1998 or so, when I really got to know Paul and Zvezda and started getting involved in this whole math circle things. It's really been a big deal to me to have that kind of support from people I admire so much. So anyway, my participation in this math circle stuff has really made a big difference to what I do in the classroom. Before I started doing the math circle thing, pretty much I taught the way textbooks teach, and I thought that was how it was done because that's how I was taught. And it wasn't how I really learned, but it's what my teachers did. And the way what I emulated was not the things that helped me learn the most. What I was emulating was the things that I had observed teachers doing. And so I was up there, pretty much following the book, doing, okay, well, here's your theorem, here's the proof of the theorem, here's some examples of how you apply the theorem, now go do some exercises, let me know if you have questions. And I thought I was doing a pretty good job because maybe I'd find a little different way to explain something, or a student would get stuck on an exercise, I'd find a different approach for them that would make sense, and I'd get through to them. And I found that, okay, I'm doing a good job here. But this is not really what teaching is all about. And that's something I really came to understand mostly by watching how much learning happens in a math circle per minute compared to how much learning happens in that kind of classroom per minute. And what I found, and I think Jim definitely is one of those people who puts his money where his mouth is in this kind of stuff. He says, well, a textbook works this way, but people learn quite a different way. And he's written the book to show, well, this is how people really learn math. I think that's what you need to do. You don't turn around the problem like he showed with his circle example. You've got to turn around the book. It's no good to put this book that does things backwards in people's hands and then have a few great teachers who are able to get up there and show people how it's really done. You have to turn around the books. But that's a tough thing to do. People don't want books that actually teach well. Teachers aren't often able to use books that actually teach well. There's a lot of stuff to do. So the kind of textbooks we use at my school, though, they really do kind of go this way. They start with a question. They say, if you want to teach about triangle centers, they start with, draw a triangle. Okay, now draw a circle that goes through the three vertices. And the students come to class with all these various egg-shaped things drawn. And we say, no, a circle. Can you really do it? Is it possible? And we talk about a lot. There's a lot of stuff you can do with that. Or we say, well, you know how to solve a compound interest problem. 1 plus r to the 10th equals 2. Solve for r. Okay, take the 10th root. We got it. Now, what about 1.08 to the x equals 2? Can you solve for x? And they realize, wait a minute, now all this taking nth root stuff doesn't help anymore. And they're led to be interested in doing some exercises to try to figure out what a logarithm is. And they don't call it a logarithm yet, probably. They probably are doing it by guessing and checking and so on. But they at least have some idea that there's something there that they might want to find out. Then you can start telling them, okay, great, we're going to talk about some of the properties of logs. Maybe ultimately we'll even prove some of the properties of logs. But it all started from the question of, well, we know about compound interest. We know about nth powers and nth roots. But now what if we ask this different question? It all starts from the question instead of ending with the question. It makes a very different way of teaching. So the math circles approach has really completely turned upside down my classroom teaching. And I would find it really hard now to teach at any other school that did it any different way instead of this kind of philosophy. So I think it's really had a big impact on my classroom teaching, and I think there's enough of a critical mass of us at my school that despite occasional criticisms and complaints of being so weird, we're going to manage to hold off the storm and stick with this kind of teaching philosophy. So I'm pretty happy and excited about that. I'm also a problem writer for math counts. And it seems to me that, like several people said yesterday, the real power of the contest is not the actual contest, but the number of kids who see the materials. And it's not about reaching the future mathematicians. It's about just at least having out there a few examples of what math is really all about. So the kids can do this stuff. It gets into their hands. Well, it gets into their hands because the things that we do in math counts are things that are topical and useful in the classroom. We have algebra, we have proportional reasoning, we have arithmetic. So every teacher can use it. It's less scary to the teachers because the topics on it are things that they know how to do. And even the problems, most of them, are easy enough that anybody can do them. So it's less threatening. It sneaks in by covering itself with all of these nice, simple algebra, geometry, arithmetic kind of problems, measurement. It gets to the big audience, and then those kids out there who are really excited about it have something to grab onto. They have those sneaky little combinatorics problems that slide in there that keep them really going and trying to figure out what's up with all this mathematics stuff. So I guess one of my big pieces of advice is don't try to take serious math and get it into the classroom, because the teachers are going to say, well, we can't do this. We don't know how to do this. We don't know what to do with this. And I'm not talking about the really bad teachers, the ones who are the track team coach who have to teach math, or the ones who became teachers because then they can go golf at 3:30 every day. But the average teachers, the people who really care about their kids, who maybe don't know a whole lot of math, who love teaching and love students, and they want to find something useful and educational to do. You got to reach those people by giving them something they understand that has these little hooks sticking out here and there. You can do a little bit of catching a wider net. So one of the things I did for this was when I was at Ghana High School, this is in 1998, the URL's just there for the notes later, I did a little workshop for teachers. And I tried to talk about problem-solving strategies, not the kind I might talk about at a math circle, but the really simple ones, like you have a problem, try an example. Be patient. You might not solve the problem in 10 seconds. It's okay. And I very carefully chose problems that even the smartest kids or teachers couldn't do in 10 seconds because there was a certain amount of trial and error, guessing and checking involved. And the smart kids would find ways to shorten the trial and error process a lot, certainly. But there's still just a certain amount of patience and organization and keeping track of where you've been required for it. And then we could talk about, well, once you have an answer to a problem, you can think about generalizing it. And way down at the bottom is all the problem-solving strategies I might talk about in a math circle, like symmetry, like invariance, like all these other really cool things that mathematicians are going to love a lot. That comes way at the bottom. We want to talk about the skills that are really useful in solving problems, but that everybody can really do. So here's the example of the problem I picked. Write 3 numbers in a row, 1 through 6. Just write any 3 numbers. Okay, great. Now everybody has something on their piece of paper. We're not going to get the staring at a blank page kind of phenomenon. Okay, write the absolute value of the differences. So you write 2 numbers down because you have your 3 numbers in a row. Write the absolute value of that difference. Then I say, okay, now try to make the whole set contain 1 each of the 6 numbers. So they probably start out with 2, 3, 5 or something, and then they didn't get very far. But then, so there's some good patience here, and there's lots of ways to generalize. How many solutions are there? What if you did 1 through 10 with 4 rows, or 1 through 15 or more, right? And so you get to see this kind of stuff where they say, well, they start out with some numbers like 5, 2, and 3 or something. It's like, well, that's pretty good. It's got 2 2s and 2 3s. Well, let's put a 4 in there. Okay, we get a 4 in there. Finally, somebody has the bright idea. Wait a minute. You got to put the 6 in the top row or it's not going to work. These types of problems, there's not a lot of deep math there. It's subtraction. A 4th grader can do it just as well as a teacher. It just takes a little patience. It takes a little bit of insight to realize stuff like you need the 6 in the top. And once you got the 6 in the top, figuring out where the other numbers go is still not done. So even the smartest kid who immediately realizes you put the 6 on the top is unlikely to just write down the solution that works on their very first try. And if they do, that's fine. You just tell them to do it for 1 through 10 and 1 through 15 and 1 through 21 and however long you need to go on until they decide that it's actually challenging for them. So I want to really encourage this type of problem, something that it's certainly lacking in some things. It's not as pretty as some problems, but it's fun to play with. Anybody can sit down and doodle it. Even a 3rd or 2nd grader can do the problem. And it teaches the really important problem-solving skill, most of all, I think, which is that you can't expect it to be something that you know how to do, plug into a formula and have an answer, but it's something you have to sit and play around with for a while. And I think this kind of attitude is something that's pretty easy to bring back to a classroom, as long as you don't do the thing of telling them how to do it and then having them repeat following the same ritual. And I think that's what Jim is showing us with his circle example. And what we need to do is find a way to change the textbooks so that they introduce things that same way of saying, let's start with the interesting question and end with the answer, as opposed to starting with the answer and ending with the question, which seems quite backwards, but nonetheless is what our textbooks actually do. So anyway, thank you very much.
Are there questions for Joshua?
what if you're not lucky enough to teach in an independent school? Oh, and by the way, I taught in an independent school, and I remember at the end of each week I'd be in tears, even though I loved my job. It was such a hard job.
Maybe you'd like to make a comparison between Castelleo and Gunn.
Right. So, I mean, I left for the independent school largely because they had a curriculum that fit this philosophy a lot better, and also because of the sanity of workload. I teach, well, nominally I teach 4 classes of 15 students now instead of 5 classes of 30, but in fact I actually teach 6 classes of between 4 and 17 now, so I don't know quite how I end up doing that, but it always seems to happen somehow. Somebody has some interesting math question they want to answer, so they ask me to teach a class about it or something. Anyway, so the workload differences definitely makes things a lot more sane, and the flexibility of the curriculum is a huge issue, but I think it's really possible to write curriculum this way and make it still cover at least close to the list of topics that, say, a public school classroom would be asked to cover. In fact, if you look at a school like Gunn, their classes cover way more than the standards call for. They cover way more than the SATs ask for. So all these pressures that are on them of meeting the standards, preparing kids for the SATs and the APs, those are there. And they are part of why I prefer teaching in an independent school. But at the same time, even within that structure, especially when you have students like you have at Gunn, it's certainly possible to teach in this kind of way, I think, and still cover enough stuff to satisfy. I don't know globally if there's really as good a solution to, can we make a national set of textbooks that'll work at schools with students not as talented as Gunn's and teach in this way and still cover these things the standards call for? I'm not so sure about that. It does take more time, and I think it should take more time. I think we should not cover so many topics, but rather uncover fewer topics. So I think for now you got to stay at the independent schools to get these things started. But I think being able to show people the success that we have and the changes it's made for us. I mean, at Castelleo is an English teaching school. Okay, all of our students take AP English, every single one. It's essentially a graduation requirement. They take 4 years of English, and the 4th year is an AP course. So there you go. And in math, up until a decade ago, math was just for the people who were good at it, right? You got sorted out maybe around 9th or 10th grade into the people who are good at math, the people who are not good at math. And the people who are good at math maybe would take 4 years, and the other ones would take whatever the requirement was to graduate, maybe 2, maybe 3 years of high school math. And now we have virtually all of our graduating students taking either AP Calculus or AP Statistics or both by their own choice. So that's a pretty huge success, I think. So hopefully we can talk to people about the success, not in terms of the rigor of the math, but just in terms of how much more our kids like math than they used to with, say, a Dulciani type curriculum. So hopefully we can make some impact that way.
Thank you, Josh. Yes, Tom, I was just looking for you. We're going to take 2 last questions, and Tom Roby, I got deferred earlier.
So a couple things I wanted to mention. One was that somebody asked about giving credit for doing math circles with teachers, and that doesn't strike me as completely impossible to have professional development units. I've been working with teachers the past 4 years, and in the 3-week all-day institutes we gave, teachers could either elect to maybe get 6 units of lower division college-level math credit or 12 units of graduate education credit for the same work. You could do one or the other. And almost all of them elected to get the teacher education credit because it was graduate level and it might apply towards something they were doing. And the lower division math wouldn't really do much for them at this point. But in any case, so these things can be worked out. The other thing is that I didn't have a lot of chance to talk about the promise for teachers bit. I think I gave that short shrift, and I really shouldn't have. So at least a year or two before 2000, the Ross program and these programs have often had high school teachers come and do the normal problem sets, but they have different issues and they need different kinds of support. And typically they're not residential. They might be occasionally, but often they're locals who come in and they're commuting in and out. And that was the case in the Promise for Teachers. And so the students tended to work at night after dinner, and the teachers would tend to work during the day. And they would often get isolated because they'd be working then, so they'd be off in their own study area. So they had their own study area and their own support things, and they weren't really interacting with the students, and this seemed kind of unhealthy. So the way to bring them together was to have these labs where you would have students work in groups with 2 or 3 students and 1 or 2 teachers, and they would work on some unsolved to them problem, some fairly open-ended thing, and try to see how far they could get over, say, 4 or 5 weeks. And then in the last week, they would, write it up and give presentations to each other. And this proved to be a really valuable collaboration because while the students had this ability to kind of, whiz ahead and come up with great ideas and things like that, they often, they had no idea what certain things were called. They often didn't have the same kind of mathematical taste that the teachers did. And so the teachers were really bringing, significant things to bear in this collaboration. They had things to bring to the table. The students had things to bring to the table. And the projects that got presented were really amazing when you would see the final presentation. So that's another thing that can be done. And I think broadening the math circles to teachers in any number of different ways and seeing what works is something we should do. Thanks.
Thank you, Tom. We'll take the one question all the way across.
When Josh talked about arrogance, that sparked a train of thought I just wanted to share with you. My name's Don Barry. I teach at Phillips Andover. And for a long time, I've been writing problems for a lot of math contests. Since '95, I've been the head author for ARML. And the word he used was arrogance. And I go recruiting problem writers. And what I find is a lot of people will say, gosh, I'm not too good at that. People here will say that as well. There seems to be a fear of writing problems for contests. And what I've learned over the years is I don't trust myself particularly, but I do trust mathematics. I particularly trust trapezoids. If I'm stuck for a problem, I just go right to a trapezoid. It gets me going because trapezoids have it all. They've got symmetry, asymmetry, right angles, Pythagorean triples all over the place. You name it. Harmonic mean, geometric mean, I'll stop. But the trapezoid is great. But lots of other things are great. I've seen distinctions made between research math and contest problems, but I want you to know that every problem that I've written involves research. I don't know where I'm starting. I just sit down. Maybe my kids are taking a test and I'm a little bored watching them. So I start playing around and start asking some questions. And they're fairly vague questions at first, and then I get a more precise question, and then all of a sudden I've moved somewhere, and I often end up a long way from where I started. But sometimes I get something, and I've just learned to trust mathematics. You've got a question that you can formulate no matter how vague. You may get dead ends, but you may get somewhere. One of the things I loved about Mary's talk is she's just fearless. Fearless. And that's a really useful quality for a math teacher. And if we're creating math circles and if we're trying to develop the mathematics instruction in this country, one of the things that I think we got to focus on is helping people become somewhat fearless. Give them the confidence that they can just do what Mary did. Get somebody going on something, even if you don't know the answer. It's nice to have the support system that she had to go to, but just to have people develop a little bit of confidence. And developing that confidence takes a lot of time. At our school, we used to run a 4-week program in the summer for math teachers. Not the best math teachers by any means, but math teachers who wanted to improve. And it took at least 4 weeks. I guess it took 4 weeks. It took 4 weeks before they were really up and running. Some of them would fight us for 2 weeks. I walked into class one day and this woman said, "Can I talk to you?" I said, I sensed something. I said, "Inside or outside?" She said, "Outside." We walked outside and she told me that if I'd come by the dorm the night before, she would have ripped my head off. She was so frustrated with the problem set I'd given, which I thought was just a basic problem set. She was so frustrated. But she was facing, really, her own inability to do the stuff. And it really upset her because she thought of herself as a professional who knew her material. It takes the time to develop the confidence in people to begin to teach in the ways that we think are the most productive. We've got a society looking for quick fixes. An afternoon session, maybe a weekend session, maybe even a week. But I think it takes a lot more time than we need. But I go back to the point, you've got to teach people to trust mathematics, that no matter what question they ask, and there's a million questions to ask, you can get somewhere with a question. And then you can help your students get somewhere to a question. And then we can get lots of people beginning to do the kind of problem posing that I think makes for the strongest and most productive math teachers.
Don, thank you very much. Let's give Joshua another hand. And I have two comments to close this session, then I'll give it to Bob. First of all, on behalf of the panel at the front of the room, I'd like to thank all of the organizers for inviting classroom teachers like myself here to the conference. And I thank the support that's given to classroom teachers throughout our nation by the research community. I believe that the research community and all those people who have a genuine interest in mathematics should be viewed as a social community of mathematicians and have mutual respect for each other. And I really thank you for helping us and to put joy in the life of our students. Thank you.
Thank you. Just two fast comments. First of all, we're going to have a 15-minute break. We're going to keep it to that.